So ray tracing is a hot topic right now, capable of pushing the envelope on what we can do with graphics rendering. Better graphics, better games, better everything, all thanks to NVIDIA and no one else. Alright, let's boot up Ghost Runner and turn RTX on, trademark, and it's already on. Okay, turn it off. Now the game's gonna look like crap. No, it looks the same. On, off. On, off. Okay, but what about Minecraft? Look at that, Minecraft RTX. This is the best looking way to play Minecraft. We just cut to BSL, didn't we? Anything, really anything could really run BSL if it can run Minecraft. Okay, so why did I buy a $2,000 computer if it does the same? Nothing looks better. It's just more expensive. Why did I buy that? So if you've drank the RTX Kool-Aid, the actual execution of what RTX is kind of underwhelming. Let's be clear, NVIDIA didn't invent ray tracing. It's been around for decades. And we've been doing real-time ray tracing since about 2010 or so. Here's a project on Dan Ball, the makers of that funny falling dust pixel game you played a bunch in middle school. I mean, it's very primitive and low res, but it is ray tracing. And you don't actually need an RTX card to use ray tracing. Anything that can handle DirectX 12 or the latest version of OpenGL will do just fine. What's ray tracing doing? And why does NVIDIA keep pushing it like it's the next must-have thing for me as a player? Well, to start off with, let's drag out some examples of not ray tracing. What did Doom Eternal and Half-Life 1 have in common? Well, both use rasterization to accomplish their look. Imagine if we had some scalable vector graphics and we plunked them right into a paint program. We have to figure out how to turn the numbers and vectors into pixels, and we end up compressing all that data down into the individual pixels we're working in. You can't get any more detail out of them. Whatever size you've imported them in at is what they're at. But if you're not going to scale the individual pixels, that is perfectly fine. It is a one-way process, but it's not destructive. We still have that vector graphic file and we can drop it in again and again. It's the same idea in 3D, but dozens of times per second. We take our 3D models, break them into their individual triangles, map those onto the pixels on the screen, then take the shader data included in those triangles, the texture maps and things, and resolve those. Then draw it all over again back onto the pixels, and again, and again, and again. Lighting in rasterized graphics isn't really beams of light, it's more shader code and shadow maps that affect the brightness and saturation and overall look of the pixels it touches. Over time, the shaders we've written have become more complex. Doom Eternal clearly looks better than Half-Life 1 to some degree, and we can use that complexity to our advantage. Rasterization is fast, and we've made it look really dang good. But it does have its shortcomings. We can't do proper reflections, but we can fudge reflections with cube maps, essentially letting us place 6 textures along an object's front, back, top, bottom, and sides to mimic reflections. We can animate those cube maps or even update them in real time with, say, cameras in the environment. Lighting's expensive, but we can fake lighting. Bake the lighting that won't move and be very sparing with the lights and shadows that will move. Portal 2 and the Stanley Parable cast shadow textures onto the map at runtime, and Half-Life 2 Episode 2 uses projected textures to draw dynamic shadows as well. These games pull off the look to great effect, and for 2012, 2013, 2008 or so, these all looked quite good, and they worked quite well. But it's a trick. It's just that. It's all tricks. All of these effects are emulating the look of global illumination using only direct illumination, because doing global illumination at real-time speeds is still kind of a white whale for graphics processing. And by faking the look, the bits and pieces, we can make games run faster, or even run at all, on modern hardware. How about we compare 2 renders from the free online encyclopedia that no one at Black Mesa will ever edit again for a second. The first one uses direct illumination, and the latter, global illumination. Now, we could fake a number of these effects. The caustic on the wall could be a baked light pointed at the wall itself. The shiny bits on the floor could be baked on with a gobo texture to give it the shimmery look as if it's reflected through the glass orb. We could implement 2 light occlusion volumes and then tint them to kind of color the space red and green respectively. It could be done. Now, if we wanted to move stuff around, yeah, that's pretty much impossible to do with raster graphics, but with ray tracing, we could start getting closer to that. Lighting and shadows aren't just shader code anymore with ray tracing. The easiest way to think about ray tracing renderers versus their rasterizing brethren is to think of rasterizing as being like a pinhole camera and ray tracing like an SLR or the camera on your phone. Ray tracing throws a line, or more accurately, a ray, out from each pixel on the camera's lens, follows it to the object, and then bounces towards the light source. Fancy mathematics will tell us how that object should look given the lights in the scene. Pinhole cameras don't have a lens, they just take the light that comes in and spits it back out. It doesn't look for the light sources in a scene, it just trusts that everything will do its job and it prints the results. Nothing wrong with that, and of course, a hell of a lot faster and cheaper. But it could be so much more. Now, what does ray tracing even let us do? Well, we can get accurate shadows and reflections every time no matter what, and none of this is baked. If you're in-engine and need to move lamps around, you don't need to sit and wait for the game to build the lighting. Just move the lamp and move on with your life. What about the transfer of color through reflecting light? In real life, the color of particularly bright saturated objects can bounce off onto other surfaces. If you wanted to do that with raster graphics, you could add some kind of colored light to the scene and bake it, but you don't need to do that with ray tracing. Accurate refractions, light shafts, volumetric light, totally possible. Minecraft RTX has some of the best looking water I've ever seen. I've played around with a bunch of different RTX resource packs, but vanilla RTX's water is fantastic. Did you like the flexibility of shaders? Surely you can't do shaders in ray tracing. No, actually you can, and it totally will talk to the shaders, and the shaders will talk with ray tracing just fine. I don't own a PS5 or the $70 version of that Spider-Man game, but one of its unlockable skins is cel-shaded to resemble one of the more recent animated films. The effect is still totally noticeable in RT mode versus performance mode in that game. Ray tracing is how we make animated films, and for good reason. It just looks good. And it emulates the properties of light pretty dang well. But when you compare it to the decades of hacks that rasterization has used, it's hard to see that. But if everything was ray traced, then we don't need the hacks, and that dev time can go towards other advances in graphics. There's one aspect of ray tracing we haven't touched on. Is it an aspect? It's kind of its own separate thing, but it's like kind of an expansion on ray tracing. You may have heard the term path tracing thrown around before, likely in regards to Minecraft shaders. I don't have any path tracing shaders on me at the moment, but I do have Blender, which has two renderers that are perfect for showcasing what a difference a change in renderer makes. So this is my scene. I didn't build it, but I did assign the materials, and I think I did an okay job. Blender's default renderer is Eevee. It's a rasterizing renderer, and it looks at the scene and just goes, yep. Well, that took all of a couple seconds. It looks alright. Looks pretty good. Now let's switch over to Cycles, the path tracing renderer, and watch it go. The image comes in initially noisy and distorted, because how path tracing works is it sends out the initial ray and then bounces off the object just the same, but when it bounces, it also sends out a smattering of additional ray casts to hit adjacent objects and bounce off of them. In real life, light works the same way. No object cleanly sends light in the direction it came from unless it's a retroreflector. It scatters it all around, and in fact, it is that scattering of light that enables you to even see things. All objects are reflecting off of all other objects. That would give us the most accurate, true-to-life look. But real-time path tracing isn't the most feasible. We could reduce the number of bounces and maybe run a denoiser through our image to help solve that. We could render it half the resolution and then super sample to fill in the missing detail. But this isn't really game ready. But damn, what a difference it makes. Minecraft shaders seem to be feast or famine right now, either being literal OpenGL pixel and vertex shaders like our rasterize and graphics of yore, or path traced with global illumination in case you want to see squares like you've never seen squares before. Ray-traced Minecraft in Bedrock looks pretty dang close to the Java version shaders, I'll give it that. The water looks good. But that's all I've really got to say on them. But yeah, we don't actually need an RTX card to do ray tracing. Nvidia does write some of their own code, but ray tracing isn't a thing they own. The PS5 and the Xbox Series both have GPUs built by AMD, and they can ray trace. You have an AMD card or an Intel card that is up to the specs of a 20 or a 30 series card, you can ray trace. In fact, my laptop could run ray tracing in Teardown on a GTX 970M. It didn't run good. I was running it low and only getting about 30 or 20 frames or so, but it was playable, and it looked pretty dang good. Ray tracing is definitely going to be the future for graphics tech, and with the increase in tensor cores and teraflops or whatever, we'll likely see full-fledged runtime path tracing hit consumer hardware within a console generation or two. Computer-generated films will likely, sooner rather than later, be rendered in real time. Developers and artists can spend less time waiting for the computer to calculate, and more time making the most of the hardware they have. Ray tracing is a developer's dream. So why the fuck is it being sold to the consumer with this much marketing hype? RTX off, RTX on is definitely an engineered meme to get people connecting NVIDIA, ray tracing, and good graphics in their heads, even if rasterization can look just as good in many cases. If it turns out that this meme was not started by NVIDIA PR people trying to make their new graphics tech a meme, I'll be astonished. NVIDIA slaps the RTX name on noise cancellation software and sells this as if it makes the games better. Adoption of ray tracing capable GPUs will make the lives of graphical artists easier. But I don't think it needs this big marketing push on NVIDIA's part. It makes it seem like a gimmick, like smoke and mirrors, despite the fact that ray tracing is more or less the absence of smoke and mirrors. A number of people online ask if AMD can compete in the ray tracing space, as AMD cards can't enable RTX. You're right, they can't, because RTX is the name NVIDIA uses for their ray tracing capable cards. And as expressed, Intel and AMD cards that can run DirectX 12 or the latest OpenGL builds can do ray tracing. Cards that are up to spec with NVIDIA's RTX cards will run ray tracing just as well as NVIDIA's cards. Asterisk. Apparently NVIDIA's deep learning supersampling is proprietary to them, and that is typically how you're getting most of your frames when ray tracing. You're only ray tracing about half the scene and then filling in the rest of the data algorithmically. I imagine AMD or an open source party will make their own version of that because that seems super helpful, but to my knowledge, that is the only NVIDIA exclusive part to ray tracing. I'm definitely probably wrong about that though, and I'm sure the comments will correct me and call me stupid. Truth be told, up until I started writing this video, I didn't get ray tracing. This was originally a rant about how I didn't think it looked good and was worth the development costs and the performance hit. I thought it was the graphical equivalent of buying a receipt. It's a fashion statement. Things run worse, it doesn't look that much better, and I get to brag about all the electricity I waste. Seems like people are doing a lot of bragging about the electricity they waste recently. We should stop doing that, maybe. I finally got a new desktop last month. I downloaded Ghost Runner and Minecraft, and I was blown away at just how little of an impact it actually makes. Ghost Runner looks the same. I'm definitely not going to play the game with ray tracing on. Minecraft RTX looks okay. I might open Minecraft Bedrock every now and again, but I'll probably stick to Java. It's not magic. It doesn't make the games better, but it's sold as the best thing for games since HD. I didn't get it, so I hit the books, I did the research, and I wrote this video. Speaking of HD, this actually reminds me of the jump from the 6th generation to the 7th. Drawing 720 lines onto the screen up from 480 is literally 50% more effort. And frame rates and performance took a hit, but it ultimately made the games better. Now we can fit more onto the screen. 4K displays can draw a minimap onto the screen with as much fidelity as a standard definition TV. And you still get the actual game too. We can fit more text onto a high resolution display. We can do split screens so much easier. Likewise, with ray tracing, visuals are a smidge better, but it costs a whole lot. But by the end of the decade, we'll be seeing what the limits of the Series X, the PS5, and the 30 and maybe even a 40 series look like. We'll be finding new ways to shade stylized games or render photorealistic ones. And maybe, just maybe, we'll have a better benchmark for impressively good visuals than PT in Minecraft. But until then, I guess I commonly come off as a curmudgeonly old man in a lot of my videos, pining for the days before always online games and microtransactions, and calling a game older than myself the best FPS ever made. But this one time, sure, kids, play on my lawn. Well, that was my Drink the Gamer Kool-Aid for the day. I think that entitles me to a gaming chair or those cat ear headphones. Let's see how many more gamer points I need so I can earn something cool. I've been saving up to try to upload my consciousness into a computer. I only need like 30 more points to do that, and I can get 5 if I make a video raving about why you need a 144 hertz monitor. No, nobody needs 144 frames. The Binding of Isaac only runs at 60. Why are you playing other games? Or Doom. Doom runs at 60. You idiot, you need more frames? What, do your eyes not work? Are you the people that are always like adding extra frames to animated videos they find online because it looks better? No, man, just leave it. Just leave it. You fool. You utter buffoon. You sack of ropes.